Hello guys. So today we will start learning machine learning as in my thumbnail that we will learn by machine learning by the book. So this is our book. So we will start from linear regression. So in chapter 1 we looked at simple regression model, life for satisfaction, theta set light satisfaction equal to theta naught plus theta 1 into GDP per capita. The model is just a linear function of input feature GDP per capita. Theta O and theta 1 are the model parameter. So basically, this is, I think, a simple linear regression model, which is which is based on classification, and it based classification on straight line, and the parameter which are governed I think it's a slope and intercept. These are the parameter by which we will classify. हाँ तो हम लोग ठीक है तो ऐसे कि अब ये लीनियर रिग्रेशन मॉडल है तो ये लिखा हुआ है y कैप इक्वल टू थीटा नॉट प्लस थीटा वन एक्स वन प्लस थीटा टू एक्स टू प्लस थीटा एन एक्स एन. तो ये सीरीज है एक. दिस लुक्स लाइक अ सीरीज. एंड वाई कैप इज अ प्रेडिक्टिव वैल्यू. सो जो भी इसमें जैसे कि ये थीटा इज अ स्लोप. ओके सो this theta naught is constant and all these things are a variable and it should be some biasness, and y cap is a predictive value. So I think we should first do a chat gpt of this equation to figure out what this equation suggests. Chat GPT is working very slow, I think, due to server. N is the number of feature. So, if anybody understand this equation, then also tell me in comment because I'm not able to connect. Y equal to theta naught plus theta 1 x1 plus theta 2 x2 plus theta n xn. What it should be. N is the number of feature, xi is the ith feature value, theta j is the jth model parameter including the bias term theta naught and the feature weight theta 1, theta 2, theta n. This can be written much more concisely using a vectorized form as shown in equation. Linear regression model prediction y cap equal to h naught x equal to theta into x. Theta is the model's parameter vector containing the bias term theta naught and the feature weight theta 1 to theta n. X is the instance of feature vector containing x naught to xn with x naught equal to 1. Theta dot x is the dot vector of vector theta, which is of course equal to theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta n xn. H naught is the hypothesis function using the model parameter theta. So what this is, I think if ChatGPT have suggest something, this equation represents a linear regression model. Y is dependent variable and x1, x2, xn are the independent variable. The theta naught, theta 1, theta 2, theta n are the regression coefficient or parameter that need to be estimated from the data. And theta naught, theta 1, theta are the regression coefficient or parameter that needs to be estimated from data. Okay, the equation can be interpreted as follow: y is function of x1, x2, xn with the coefficient theta 1, theta 2 theta n, determining the impact of each development variable on the dependent variable. Theta naught represent the intercept or constant term in the model, okay, which is expected value of phi when all independent variable are 0. The goal of linear regression is to estimate the value of theta naught, theta 1, theta 2. Okay, so I think uh, we need to figure out the this hyperparameter tuning in the equation by giving predictive value and the features value. Okay, I get some sense. N is the number of feature. Xi is the ith feature value. Theta j is the jth model parameter, including the bias term theta naught, and theta j is the jth model parameter. Okay, including the bias term theta naught and the okay. What means bias term? We should search it. What is bias term? Don't know why today it's very slow. Chat GPT. In the context of machine learning and statistical modeling, bias term refers to the constant term or intercept represented by theta naught in the linear regression in a model. It is an additional parameter that represents the expected output of the model when all input features are 0. The bias term helps the model to better fit the training data by adjusting the vertical position of regression line or hyperplane without the bias term. In the context of machine learning and statistical modeling, bias term refers to the constant term or intercept in a model. It is an additional parameter that represents the expected output of the model when all input features are 0. Okay, okay, that's mean when all the features are 0, then the theta naught represent the predictive value. Okay. The bias term helps the model to better fit the training data by adjusting the political position. The bias term helps the model to better fit the training data by adjusting the vertical position of regression line or hyperplane. Without the bias term, the model would be forced to pass through the origin. Oh yeah, sure, which may not be appropriate for many real world data sets. Yeah, absolutely. In other words, the bias term allow the model to learn a better representation of relationship between the input feature and output variable, and it can help to reduce the error or loss function of the model. So do you understand, guys, what is bias? So basically it provides a model to allow itself to represent in a better way, let's say that all there are no there are if there is a line which is passing through the origin. Okay, so it would be restricted in origin, and so there might be a very much situation where it will not able to classify the model in proper way. So that is why theta naught is set in the equation, so it can yeah go through the intercept, and it can freely move in the axes. So that is why I think theta naught is here. Okay, and so this is the y cap equal to this is c or plus mx, or Okay, or this equation is like mx. Okay. This can be written more concisely using a vectorized form. Let me show what is vectorized form. What is vectorized form? What is vectorized form? In computer programming, vectorized form refer to the use of vector or matrix operation. Some refers to the use of vector or matrix operation to perform computation on multiple element of an array or dataset simultaneously. Instead of using iterative operation or each element individually, vectorized operation are typically much faster, and in computer programming, vectorized form refers to the use of vector or matrix operation. Use of vector or matrix operation to perform computation on multiple element of an array or dataset simultaneously. Vector or matrix operation to perform computation on multiple elements of an array simultaneously. Instead of using iterative operation or each element individually, vectorized operation are typically much faster and more efficient than iterative operation, especially for large, typically much of the more than iterative. Vectorization are commonly known in mathematical scientific computing as well as in machine learning and deep learning framework. For example, in NumPy, a popular Python library for numerical computing, many mathematical operations can be performed using vectorized functions that operate on entire array or metric at once rather than looping through each element. Vectorized form can also help to improve the readability and maintainability of code as it allows complex computation to be expressed more concisely and more intuitive way additionally. So I think it is a some type of mathematical form which help to compute in a data set. And like can you give some example? Can you give some example of vectorized form? Sure, vectorizing Python using NumPy array, element-wise addition of two array, and p dot array print c. Okay, okay. So any operation which is done in matrix, I think, is dot product or cross product. These types of things are called vectorized. Okay. Yeah, it is a dot product of theta dot x. So that is why it is a vectorized form. And h is a function of x. Theta is the model's parameter vector containing the bias term theta naught and the feature weight theta 1 to theta naught. Okay, x is the instance feature vector containing. So it is basically a dot product. X is the instance feature vector containing x naught to xn with x naught always equal to 1. Theta dot x is a dot product vector, of course. H naught is the hypothesis function using the model's parameter. So yeah, it's the hypothesis function. I hope we will learn in book later about these things. In machine learning, vector are often represented as in machine learning vector are often represented as column vector, which are 2D arrays with single column. If theta and x are column vectors, if theta and x are column, then prediction is y cap equal to theta transpose x, where theta a row vector instead of column vector, and theta transpose is the matrix multiplication of theta and x. It is of course the same prediction except it is now represented as a single cell matrix rather than a scalar matrix. In this book, we will use this notation to avoid switching between dot product and matrix multiplication. Okay, okay, that's linear regression model. So now how to do it? We'll recall that Training a models means setting its parameters so that the models best fits the training set. For this purpose, we first need a measure of how well or poorly the model fits the training data. In chapter 2, we saw that most common performance measure of regression model is the we saw that most common measure of regression model performance measure of regression model is root mean square error. Therefore, to train a linear regression model, you need to find the value of. We saw that the most common performance measure of regression models to root mean square error. So, have you guys know, in root, I will tell you about the root mean square error. So, in this, it basically it calculates the difference between actual value and predicted value, or we can say that how our model operates in real world data. So, in root mean square value, so first what we do is first we take a root of values, and so first what we first do, first we square all the values, then take their mean, and then take their root. So that's how it gives us a value, it gives a distance. So basically, like when you, so you were thinking like how it gives the difference between predictive value and actual value. So when we do you can say there are you are doing some operation and your output, your predictive value is 7, and predictive value is 7, and your actual value is 5. Okay, so how you will create a how will you know that how it's how much it varies? So you subtract, like you will do 7 minus 5 equal to 2. Okay, but let's say you have a lot of data, so every point there are some actual value, and there are some predictive value. So how will you calculate how much your model is deviating from? So basically what will you do, basically there is only a one is statistical method which we call is a mean. Okay, then or how we take the mean, we can do what we can do now, like subtracts all the value and take the mean. But for to do that, there will be a one problem, that some value can be negative and some value can be positive when you only divide, right? So the output can be 0 and you think that your model is very accurate. But so to optimize this solution, what we do first, we take first we do what we do, we subtract the value, xi is our predictive value and x naught is our output value. So we do a square of these value and then take the under root. So always we get a positive value. So that's how we use a root mean square value to to measure the performance of the model. Therefore, to train a linear regression model, you need to find the theta naught that minimizes the RMSE. So yeah, so it's telling that we have to find a theta basic intercept so that we can minimize our error or maximize our model's performance. It is simpler to minimize the mean square error than the RMSE, and it leads to the same result because the value that minimize a function, yeah, also minimize its square root. So mean square error for linear hypothesis of training set is calculated using a cost function of linear regression. So this is the function where x comma h naught and 1 upon mi equal to summation I equal to 1 to m theta uh, theta t and xi minus yi. So uh, basically theta t and xi is predictive value and yi is actual value. Okay. So okay, let me try to write in a open. I tried paint but it didn't work too good. Why I'm not getting good options? Let me check. Uh, what should we do? I think it doesn't have a 3D. I see some online paint tool. It's not good. Free online editor. I don't know why they are so bad. So bad. Okay, then I think we cannot learn in pages or something. No issue. Uh, so what is this mean square? So as you can see, like, see, this is predictive value, okay, and this is actual value. So first, what they did, they subtracted a value, okay, and then they square. So what they will do, like for one I equal to 1 to n, they do the same thing, like they always subtract a predictive value and actual value and take their square, and after that they will take their mean value. So this is the mean square error. The only difference is that we write h naught instead of just h in order to make it clear that the model is parameterized by the vector theta. To simply simplify notation, we will just write MST instead of MSE. Okay. The normal equation to find the value of theta that minimize the cost function. There is closed form solution. Okay. The normal equation to find the value of theta that minimizes the cost function, there is closed form solution. In other words, a mathematical equation that gives the result directly. This is called the normal equation. Okay. So what is this equation? Theta cap equal to x cap x transpose x inverse into x transpose y. What is this? Theta cap is the value of theta that minimizes the cost function. Y is the vector of target value containing yi to ym. Let's generate some linear looking data to test this equation on. What is this equation? We should look at it, right? I don't know why when we the expression you provide represent the formula for calculating the parameter theta of a linear regression model using the least square method. Okay. Theta, a vector of regression coefficient of where the net need to be estimated from X, a matrix of independent variable or feature. Okay, we will. The expression you provided represent the formula for calculating the parameter theta of a linear regression model using the least square method. Theta vector regression coefficient of parameter that need to be estimated from the data. X, a matrix of independent variable or feature where each row represent a single data point and each column represent a single feature. X, a matrix of independent variable or feature where each row represent a single data point and each column. Okay, then they multiplied with their transpose and take a inverse. I don't know, like this formula can first x is multiplied by its transpose and then inverted. This product is multiplied by x transpose and dependent variable y to obtain the estimate at the least some but it does not make sense to me. But it does not. I am sorry that the explanation didn't make sense to you. Let me try. The formula is provided a way to calculate the optimal linear regression coefficient theta for a linear regression model given a set of input data and the corresponding output values. The basic idea behind linear regression is to find a line in the case of simple linear regression or hyperplane. In the case of multiple linear regression, that best fits the input data and can be used to predict the output values. The basic idea behind linear regression is to find a line. So in the case of simple linear regression or a hyperplane, the basic idea behind linear regression is to find a line. In the case of simple linear regression or hyperplane, in the case of the basic idea. Okay, so it is telling that the basic idea of linear regression is to find a line, as I told you earlier, that we have to find a line which can classify our features. In the case of simple or a hyperplane, that best fits the input data and can be used to predict the output value. The line is defined by set of regression coefficient that determine the slope and intercept of the line hyperplane. It seems very cool. To find the optimal value of regression coefficient, we use the least square method, which aim to minimize the sum of square error. To find the optimal regression, we use the least square method, okay, which aim to minimize the sum of squared error between the predicted value of y and the actual value y. In other words, we want to find the regression coefficient regression coefficient that result in the smallest difference between the predicted value and actual value. Okay, the formula unit is one way to calculate the optimal value of regression. Okay, somehow I think it is calculating theta by which uh, I don't know like how, but why this formula and book is telling us that we should test first. Okay, then import numpy x equal to 2 into np dot random dot rand 100 comma 1. So in my knowledge np dot random dot rand, it will create a matrix of 100 cross 1 and fill a random values, and then they are multiplying it by 2. Okay, let's also check in chat gpt that I'm explaining right or not, because I'm also new in machine learning, that is why. But I thought to stream though. It might help also others who want to learn with me. And after that, we also will create some real world product, like not product which are also in internet, but like a usable product after creating after learning. So if anybody want to join, they can ping me so we can connect. The line of code you provided generates an numpy array of shape 100, with random value between with the random value between 0 and 2. 2D array with random value. Each element array is generated in each element of array. Each element of array is generated independently and uniformly at random from 0 to 1. To multiply each element of the array by 2, resulting in an array values between 0 and 2. So the final result is okay. Have you understand? And again, then is what is here, and for y, what it is doing 4 plus 3 into x. So y is the function of x. Okay, so we can see that 4 is I think a theta naught, and plus 3 into x, 3 np dot random rand 100 now we should, its sum of cells are still learning. I think I should open notebook then to learn this. Think now this opened. So we can open the project. It's taking time to load. So first we will copy this line, then we will copy this line, Now I will execute these lines and it's giving me error saying that input import, so I will import numpy, import numpy as np. It is often the case that learning algorithm will try to optimize a different function than the performance measure used to evaluate the final model. This is generally because that function is easier to compute because it has useful differentiation properties that the performance measure lack, or because we want to constrain the model during training, as well as we will see when we discuss regularization. Okay, the demonstration that the returns the theta that minimizes the cost function is outside the scope of this book. The demonstration is showing that the theta that minimizes the, yeah, so of course, like we will discuss that how it is uh, m- diminishing the error, how it is equation works. So like I think we will never know because this is telling that random generated linear data set. What this line does. Okay, 1 minute. X1y, so randomly generated linear data set x comma b and p dot c and p1 standard comma 1 x, add x theta equal to 1 to each instance. Let me check in chat GPT what this line mean. The line of code you provided concatenate a column of 1 to an existing numpy array x. The line of code you provided concatenates a column of ones to an existing numpy array x to create a new xv with an additional column. Here's a breakdown of what each part of the line does. np.1 and create a 2D array of shape 100, 1 filled with 1. np.1's np.1's create a 2D array of shape 100, 1 filled with 1. This array represents the bias term. This array represents the bias term or intercept in a linear regression. Okay. np.say x concatenates a column of 1 to the array x along the second axis, that is column axis using the concatenate the column to the array x along the second axis, that is column axis, using the np.c function. The purpose of adding the bias term to the input data is to allow the linear regression model to make prediction even when all input features have value of 0. Without the bias term, the linear regression model would have passed through the origin, that is have 0 intercept, which may not be appropriate for all data sets. By adding a bias term, we allow the linear regression model to shift the line hyperplane up or down to better fit the data. So you understand that this equation means like np dot one's telling to create a matrix of 100 cross 1 which will be filled by 1, and then it get concatenated in x-axis. Okay, so basically, as I told you, y equal to mx plus c. So it is creating a hyperparameter theta best equal to nb dot lineal g ni line alg dot inv xbt dot what that line, it's very tough looks like. See what that line supposed to mean. The line of code you provided calculates the optimal value of the regression coefficient represented by theta best. The line of code you provided calculates the optimal value of regression coefficient. The line of code you provided calculates the optimal value of coefficient represented by theta best for a linear regression model using a normal equation method. So I think it is using this method which is they explained here, this equation they are using, what I can think. So here's a breakdown of what each part does. So first it is telling x higher x underscore b dot t, x underscore v dot t, where is x underscore v dot t. So this is the term first. It is transpose of matrix xb, which we get here, switching its rows as column. This is necessary because the normal equation method requires the input data to be in a matrix from where each row represents a single data, where each row represent a single data point and each column represent a single feature. Okay, let me drink a water, but I don't think I have a water. The actual function that we use to generate the data, the actual function that we used to generate okay, first we will like study an xbt dot xp, like first we this thing should be computed like this is, then this should be computed. So it's the whole dot product dot x hyphen b x underscore b. Wait 1 minute. Now let's compute theta cap using the normal equation. Okay, and dot in the xb, which is the concatenated form where theta is added, uh, the matrix, so they transposed and then they multiply it, Then so basically, yeah, it is the same equation, and then they multiplied it by dot y, the actual function that we use to generate the data is y equal to 3 plus xi Gaussian noise. Let's see what the equation find. 4 plus 3, yeah. So put these two equation here. It run. Now we will calculate theta west. Theta west. So it providing me a two value 4.00726428. So we would have hoped for theta naught equal to 4. We can also like do more checking like by uh, print print x, right? See what happens. 1.5, 1.28. So these are the value it had filled. Now print y. Okay, then I think this should be a small y. And so they are the value calculated y. Then print x b. So it got multiplied one dot. Okay, so it got concatenated with the value x, and then it got only 1 cross 1. Sorry, 1 cross 2. We would have hoped for theta equal to 4 and theta 1 equal to 3. Instead, theta naught equal to 4.1215 and theta close enough, but this noise made it impossible to recover the exact parameter for the original function. I don't understand what that means supposed to mean. Two into np dot random rand 100 comma 1. Now you can make prediction via this equation y equal to 4 plus 3x. So you can see that 4 is there and theta 1 is 3, but like this should be, but there are, but the noise made it impossible. So I think they are saying that y equal to was 4 plus 3x, but we were calculating theta. We didn't get the exact value of our parameters. Okay, So it's saying that close enough, but the noise made it impossible to recover the exact parameter of the original function. Okay, now you can make prediction using theta cap. X new equal to np dot array 0 comma 2 uh, np dot array, what that is. All rows are run or not, is still running. It's very slow. I think there are not too much left rows. The line of code you provided create a numpy array with two rows and one column. The line of code you provided creates a numpy array with two rows and one column where the first element is 0 and the second element is 2. Where the first element is 0 and the second element is 2. Here's a breakdown of what each part of the line does. np.array creates a new numpy array. 0, comma 2 specifies the value of the array as a list of two lists where each inner list represents a row of the array. The first element of the first row is 0. Where array with two rows. Okay, and okay, there are two rows and there are only 0 or 2 element. Okay, I understand now. Okay, so first we will execute this equation. X new b equal to np dot c np dot 1 2 comma 1 comma x new. So x new b what they are first np dot 1 what it will do, it will create a array 2 cross 1. Okay, and it was filled by one value. Okay, and then it got concatenated with the x new. Understand? Y predict. Y predict. Y predict equal to x underscore new underscores b dot theta best. X new. Okay, so this is matrix dot theta, that is a y predict. Now print y predict. X predict equal to x underscore new underscore b dot theta best. So this is the matrix. I think first we shouldn't like do all the things like that. First we should print, so it will make sense. Print x new. So you can see there are two rows, and then second line is x new b equal to, so it got concatenated. X new b. As you can see, there was 0 or 2 element as here they mentioned, and it got concatenated with 1. Y predict. So now with theta best, as you see in theta best, or you want to see again theta best, theta theta underscore best. So it now it will multiply by this number. Yeah, basically we will take a dot product. No, not this line. We have to copy this line. Y predict equal to x underscore new underscore b dot dot. So it will do a dot product and see what y should be. Y predict. So it gives a value 4.0, 9.7, 4.0, 9.7. Let's plot this algorithm. Y predict. But to run this, I think matplotlib library should be here. See, I can run or not. So as you can see, there are mentioned x new y predict r. So this is r dash, which mean this equation will be painted by red color with dash, and plt dot plot x dot y. This curve will be painted by blue, but I think it will not run. Yeah, matplotlib. So we have to import matplotlib. Import matplotlib as plt. I think matplotlib. Let me check. How to import matplotlib. Import, yeah, pyplot. Plt.plot. So uh, it created the value. There are two lines plt.access 0 to 015. I think I should add also both those two. Now run. So basically this plt.access is telling that x-axis should be 0 to 2 and y-axis should be 0 to 15. Performing linear regression using scikit-learn is quite simple. Yeah, 1 minute. minute. Hello, 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 hello.